Alright, what's going on, guys? Welcome back to the Ovens Garage. Today I'm going to be attempting to repair this PCM out of my 1992 Dodge W250 Club Cab. This truck was originally an automatic truck and I converted it to a 5-speed Getrag. If you watch my previous two videos, I show you how to go through the finding diagnostic codes, and then I also show you how to swap out the PCM. So because I have two trucks, I swapped out a good PCM, a known good PCM, for the bad PCM in my red truck, and I figured out that the PCM was indeed the problem. So go ahead and watch those two videos if you haven't already, if you're running into similar PCM issues that I was having. So what I'm going to do in today's video is do a deep dive into this and hopefully be able to resolve whatever the internal problem is to the computer. And if you dive into yours, I'm hoping that this helps you out and you can do the repair yourself instead of having to send off your computer for a repair or find a used or reman computer for hundreds of dollars. So let's dig into it. All right, so I'm just going to start by using some spray 9, and I'm going to clean up the exterior of all the dirt and grime. Alright, so take a T15 screwdriver and remove the 4 screws on the front. Actually, maybe 5. It looks like I'm missing one up here. Alright, now that I've got those screws off, I can pull the lid off. Alright, so at a first glance here, just looking under the lid, it looks like we do have our printed circuit board, but it's underneath this like squishy gel foam type of covering. Now, I'm assuming that is there to protect the electronics on the circuit board. So I don't know if it's going to come off easy, but we'll see. There's a few capacitors poking through here that we could potentially take a look at. There's a big heat sink here, so we'll pull the heat sink off and take a look and see what's underneath there. All right, so what I think I'm going to do here is I'll probably pull off some of this gel coating off the PCB. Typically on some of these computers, the capacitors will go bad. It's common with any electronics. Over time, capacitors will age and sometimes they'll pop, and just because of overheating, they'll actually pop at the top or pop right out. I've seen a couple photos of these PCMs where the capacitor, like up here, was completely out of the circuit board. So what I think I'm going to do is I'll pull this gel off. I'll take a look at the components on the circuit board, and maybe I'll desolder these capacitors and test them to see if they're good, and then replace them and see if that does the trick. Alright, so I'm at the point now where I've peeled away all the this gel type stuff. It's very hard to get off. I haven't tried to use heat yet. I might try and use heat after, but I peeled away along all the edges, so I'm at the point now where I can peel the entire board back. And we're getting the first look at the front side and then the back side. So you can see it looks like there's another coat of that gel on the back. But we've got it away from the casing now. Alright, so I just wanted to give you an update here. So this has been a pain in the butt trying to remove this silicone type covering that's on both sides of the PCB, but I've managed to get most of it off, and now I can start inspecting some of the components just to see if there's anything wrong. At a first glance, I don't see anything glaringly wrong with this. Like, there's no burn marks in the traces. There's no, basically like burnt out components that I can see with my, the naked eye. So what I think I'll do next is I'll tackle removing, there's these 3 capacitors. So 1, 2, and 3. And I'll test them each and replace them. And maybe that'll be it. I'll do a bit more research as to what some of the other components are. I'm not quite sure what this one is, but I'll look around and see what they are. It looks like there's some surface mount diodes and maybe a couple resistors in here. You know, there's one here. So I'll test most of these guys, and we'll see if I can figure out what the problem is. Okay, so I've removed those 3 capacitors. There was 2 up here and then the one over here, and I can proceed to test them. I marked them all. I figured these 2 smaller capacitors were both the same size, 25 volt, 220 microfarad, 105 degrees Celsius rated capacitors, and this larger one that was next to the other small one here was 25 volt, 470 microfarad, and 105 degrees Celsius. So I've got a kit of cheap capacitors. I might try and look for some better ones before I replace them, but I'll go ahead and I'll test these 3 now. All right, so I'm just gonna show you how I check these capacitors. I've checked them all already and they seem okay, but I'm gonna replace them anyways. So you take your multimeter and put it on 20,000 ohms of resistance, and then you take your negative and your positive lead of your multimeter. We'll grab one of the capacitors that was in here. This stripe is the negative side, the other side's the positive side. Usually if there's a long lead on one of them, it's the positive side, but both these are the same. So we know this one's the negative side. What we have to do before we test it is short the 2 leads out together, just for a second. And then we'll take our negative, put it on the negative. And then before we put the positive on the positive, what we want to see is we want it to see an increase in its resistance value until it goes back to 1. And that'll tell us it's a good resistor. If it doesn't go all the way back to 1, or if it kind of fluctuates and doesn't go to the open circuit, then that's how we know it's a bad capacitor. So there you can see it slowly increasing, and then eventually gone to the open circuit. Now you can see, obviously, if we test it again, you can't do it again. You've got to re-short it out with a screwdriver. Test it again on your negative, and then your positive. And there we go. So yeah, there we go. So that's how we know our capacitors are good. Like I said, I've checked them all and they're good, but now's the time to replace them while they're out. All right, so I got a little excited and I couldn't wait for my new capacitors to come in, because I want to say that the capacitors are the problem, because capacitors on a circuit board are one of the things that do go bad over time. So, you know, the average lifespan of a capacitor is probably like 20 years or so, maybe 30 years, and they'll start to go bad. So I replaced all these with my cheap Chinese capacitors for now, and I've ordered some nice Panasonic ones that are on the way. And I'll give this a shot in the truck now. I just soldered them in lightly, and we'll go try it in the red truck and see if it solves our problem. And if it does, then great. Then I've, you know, identified what the problem is, and then I can get the nice capacitors in there, and I'll have to find some sort of coating to go back on the PCB. So let's go give that a shot in the truck. All right, so I'm out in the red truck now. What I've done is I've plugged in the PCM. It's not an X casing or anything. It just has those cheap Chinese capacitors in it. So we'll see if the truck does its regular startup procedure. So what I'm looking for here is for that water and fuel light and the wait to start to come on. And I'm gonna listen to the grid heaters come on too. All right, that's a good sign. We'll fire up the truck here and see if we get a charge and tack. All right, so we've got tack. That's a good sign. And in here, it's probably going through its post-heat cycle again. So we're sitting at just over 10 volts there. There you can see it jumping back up to about 12. So I'll let it warm up again and we'll see if it's charging. If that's the case, then we found the problems and it's with the capacitors. All right, so I've managed to get everything working. I checked the charging voltage and it still wasn't charging. So I don't know if that's just because it's not done the post heat cycle yet or because of some other reason, but everything else is working. My AC is working, my TAC is working, the whole startup procedure is working fine with my water and fuel and wait to start light. So it seems like I've resolved most of the issue. So except for that charging problem, which seems a little bit odd to me. So I don't know what that is or if it's a separate issue, but I also tested to see the diagnostic procedure. So the off, or from the off position, the on, off, on. And it did start giving me codes, which means I guess I've repaired the PCM in that aspect as well. So yeah, it's good news. Can't wait for those nice capacitors to get in, and then I'll wrap up this install. All right, so that was a pretty good success there with those cheap capacitors in there. My whole startup procedure worked great. My water and fuel light, my wait to start worked fine. My grid heaters turned on. It still did my post heat cycle. The only issue I noticed was the voltage regulation. Or I guess not so much the voltage regulation, but the charging was not working. So I don't know if that's an issue internal to the PCM. I didn't confirm whether or not the alternator was putting out a charge. I guess that'll be kind of my next step here. I'm also curious as to which piece inside the PCM does the voltage regulation. So I'll look up some of these part numbers on these integrated circuits and see what is actually doing what. I want to say, I don't know, like maybe this piece here or this piece here or this one does the voltage regulation. We'll see. I'll look up some of these part numbers and see what I can find out. And then in the meantime, I'll confirm that my alternator's charging and that all my everything else in the charging system is working before I suspect it's the PCM. All right, so I just received my good capacitors in the mail. Both these are Panasonic capacitors. I'll link the capacitors in the description box below. So I've got my 220 microfarad and my 470 microfarad capacitors to replace these 3 cheap Chinese capacitors that I put on there in the interim. So I'm hoping that getting the good capacitors on here will solve my voltage charging problem. And I guess we'll find out. So just note the polarity of the capacitors. So the negative is facing in for these two, and the negative on this capacitor is facing up towards this connector. So what I'll do is I'll desolder these, solder in the new guys, and we'll throw it in the truck and give it a test. So these are the two 220 microfarad, and this one here is the 470 microfarad. All right, so I've soldered the 3 capacitors in from both the bottoms and the tops. I checked with the multimeter to make sure I have good continuity between some of the ends of the capacitors and some of the other points on the board. So, for example, I would test on one leg here and then follow the trace to the closest open point for testing. Put my multimeter lead on each end and make sure it tests for continuity. So for example, I'll show you this one. Just to make sure you're getting good continuity on each one and you don't have a bad solder joint, I'll take one of my multimeter leads. I'll put my multimeter on continuity setting where it beeps like that when I have continuity. Put it on one leg, right here for example, and then over there, you know, that makes sure that I have a good continuity. Then I can do that, you know, for all my capacitors on each leg to make sure that I've soldered them correctly. So at this point, I've got my good capacitors in here, so I can go and dry assemble this and throw it in the truck and see if my problems are solved. All right, so let me explain where I'm at now. So again, I'm at the issue of I've solved all the problems except for the truck is not charging. So what I did was I installed the PCM in the truck, and then I tested a few things, and I figured out that my ASD relay is not engaging. So when the ASD relay engages, it provides power. I believe it provides power to the field circuit of the alternator, which then allows the alternator to essentially turn on and provide a charging voltage to the rest of the system. So the way this is working is what I did in the truck was I just jumped the ASD relay on the opposite side of the energizing circuit. So right here, you can see between, I don't know if you can see this very well, whether or not it's blurred, but between pins 85 and 86 of the relay, that's the energizing side of the circuit. And on the bottom, between pins 30 and 87, I jumped those two wires. The colors of those wires is red from the battery, and then there is a dark green with an orange stripe. So jump those two, and that provided power to the alternator, which in turn charged the truck. So that told me that something's not engaging the ASD relay. So I couldn't figure out what it was within the PCM. So what I'm going to try and do is just what the PCM does is it provides a grounding circuit to the ASD relay. So what the PCM actually does is it senses when the truck is running from the crank position sensor, and then once it recognizes that, it turns, or it provides the grounding circuit for the ASD relay through the PCM, which in turn energizes that relay and then provides a charging voltage to the truck. So instead of trying to figure this out, because I couldn't quite figure out the charging issue, and you might not have the same charging issue that I have just after replacing the capacitors, but I did. So what I'm going to do is I'm going to provide a ground to that ASD relay every time the ignition's turned on. So what I'm going to do is I'm going to ground out from the pin that provides the ground to the ASD relay, which is pin 51. And that's outlined here on this diagram, which I can throw up on the screen. The output from pin 51 energizes between 85 and 86 on the ASD relay, which in turn allows power to flow from basically the battery to the alternator. So everything else still works, and it's interesting that they call it an ASD relay, which also stands for automatic shutdown relay, because all it controls on the diesel trucks is power to the alternator, whereas on gas engines, I believe it controls things like the fuel pump and to the power to the ignition coil. So when there's not power to your ASD relay, the vehicle won't run, but that's not the case in a diesel. So, you know, when guys have a problem with their ASD relay, it doesn't really affect much except from charging. So what I'm going to do, basically, because I don't think it's unsafe at all, is just to provide that ground to the ASD relay through the PCM somehow. And every time you turn the key on, so from the ignition switch, has power all the way up to this side of the relay. Whenever you turn that key on, powers up the, whenever you turn the key on, power goes through the ignition switch into the relay, and then the ground is already there in the PCM. So every time you turn the ignition switch on, you'll get power to the ASD relay, and then when you start the truck, the alternator will charge. So we're looking on this side here, like I said, pin 51, which is this bottom left one here, and this is when you're looking at the connector itself. So when I'm looking at the back of the PCM, this is actually correct. So this bottom left one here on the right hand side is the one that I'm going to need to ground. So I'm going to take a wire of some sort. I've got a small, jumper wire kit here, and I'm going to ground it from that pin to a common ground. And all these large copper areas here. These are all the common grounds. So what I'm going to do is jump it between this pin and then maybe one of these small sections here, and then I'll go throw it in the truck and we'll see if it charges. And it should charge because that grounding circuit is provided and energizes that relay every time I turn the ignition switch on. Alright, so it's not the prettiest, but I did jump the wires. So between pin 51 and then just there's a couple small grounds here. And then I'll show you that now there's continuity from that pin to ground out that circuit whenever it's energized. So I'll show you between, that's the pin and then a ground. So I can go to any ground now, you know, over here. Oh. Over here, and it works. You know, I make sure I have continuity between the wire itself, any other point. So I've got a good common ground there. So I think that'll work. Again, there's the jump between those two connection points. So I will dry assemble this again, go throw it in the blue truck. The blue truck, but just because it has the battery in it and everything right now. And then we'll see if it charges. All right, the refurb PCM is in and I've got a charging voltage. I'm sitting at 8, 10, 12, just under 14 volts. My tach's working. We'll go test out overdrive, see if overdrive is working. And like I said, AC doesn't work in this truck. But I'm pretty happy that little grounding trick worked. And everything's working like it should. And I don't have an external voltage regulator. I don't have a one-wire alternator. I just got the factory PCM, replaced the capacitors, and then I grounded out that ASD circuit within the PCM itself. And everything's working as it should. All right. Alright, so we'll go through the cycle here. Truck's off. Does my startup procedure right. Check engine light, oil pressure light come on. See if we'll get our check engine codes. Oh, I can hear my grid heater relays, so I know that's working. Looks like we're getting our check engine codes too. And we're also getting our tach. Our overdrive light, also controlled by the PCM, works. And the overdrive works too. So that all worked out pretty well. So now what I just have to do is go and find a material that I can protect the PCM with. So I was thinking about getting, just from Canadian Tire, some silicone, some GE silicone number 2, something that doesn't when it cures is not acidic and it won't damage the electronics. So I was thinking about maybe doing that, but I'll do a bit more research and then figure out what I want to use. But that's a success. So I can take this PCM out now and go take it back to the workbench and do that little bit of work there. All right, and so that was a success doing that jumper circuit between pin 51 and the ground, common ground on the PCM. So I just wanted to note that this isn't the proper fix. So if you decide to do something like this, it's at your own discretion. This isn't the way the PCM was meant to operate, but it does make the whole system work, and it still charges the truck. So doing this sort of jumper wire is probably not a great idea, but it does work. So if there is something like a short in that circuit, chances are it's going to fry the PCM or something like that. But I don't think it's any less safe than just having something run through your ignition anyways. So you know, I'll keep an eye on it and we'll see how it works in the future here. So second lesson learned here for doing this PCM repair, and if you do a PCM repair to yours, is this potting material that was on here, all that silicone all over the front and the back. If I were to do this again, I would probably only remove the potting material around here on the front side and the back side just to change the capacitors, and then a little bit here to change the capacitors. And then what I would do is grab some silicone like this, some GE silicone 2, which is non-acidic or corrosive when it dries, and I would reapply it just in those small spots. So what I'm gonna have to do here, just because it costs, I think it costs like $100 or $150 just to get like actual potting, electronic, like PCM, or sorry, PCB potting material, and you know, this is only 10 bucks a thing, so I'm just going to use this instead. And so what I'll do is I'll apply some silicone to the bottom, I'll press in the PCM, and then I'm going to do silicone all over the top of it. It's not going to be neat by any means, and it's definitely not the proper way to do it, but that's the way I'm going to do it. Alright, so it ain't pretty, but it's gonna work. So I'll let this cure for at least 24 hours, and then I'll go ahead and throw it back in the red truck and we'll be done. So it's the next day here, and I've got the remanufactured PCB back into the red truck. So we'll see if everything works properly the way it should, and we'll go for a nice little test drive. Okay, my grid heaters are on, my water and fuel, my wait to start light came on, just as they should. I can hear my grid heaters. Okay, my grid heaters clicked off. There we go. I've got my tachometer. Throw the lights on here. Here we're still doing my post heat cycle. And I'll come back and show you when it's fully charging, and then we can go for a little test drive. All right, and now you can see it's still doing its post heat cycle, but I'm going between just under 12 volts when the grid heater is on, and then just about 14 volts when the grid heaters are switched off. That's good news. All right, so I'm just out here for a test drive. Everything's working as should, except for my dash lights. I mean, that's just a separate problem with my LEDs, but anyways, I've got a charge sitting at about 14 volts. My startup procedure worked well every time. Let's just get around the corner here. All right, guys, so I'm out here on the highway. I just tested out cruise control. Cruise control works now. All right, I mean, it's not like it didn't work before, but cruise control works. This is a manual truck, so I don't know if overdrive would work, but I tested it in Old Blue and it worked. I've got sitting at 14 volts of charge, and like I said, my startup procedure worked great. I haven't tested AC, but AC has always worked in this truck. So yeah, no, I think we could call that repair a success. It's not really the perfect way to do it, but I did resolve the problem, and I kept it all internal to the PCM to repair what the issue was. So, you know, for the cost of what, like maybe $10 in capacitors, and you know, a few days of my time, I repaired the PCM for what the cost of sending it away to actually get repaired probably would have been, you know, hundreds of dollars at least. And you know, buying buying a used PCM out of like a parts truck or something would, again, probably run you a few $100s. So I think this is definitely a repair that you can do yourself at home, as long as you've got the right soldering tools and you have a little bit of patience. You can definitely do this yourself. I've actually got I've got another PCM on the way
I reached out to a guy who had an old PCM that wasn't working in his truck, and I'm gonna try the same thing because I have a few extra capacitors. I'm gonna go through, and this time, instead of removing all the potting, I'm just gonna remove the potting around where the capacitors are and replace those, and then just fill around them with silicone, so that way it's a little neater. And then we'll see if that fixes the problem on that PCM, and maybe this charging thing was just isolated to my PCM. All right, thanks guys. I really appreciate your support through all these videos. I'm hoping that this video really helps the community out, because I know there's lots of guys who have PCM problems. And yeah, so there's lots more to come with the red truck and the blue truck. I don't really have projects lined up specifically. I've just got like a giant list of things I've got to do to both trucks. But this one's been on my list for a while, and I'm pretty happy that I fixed it. All right, thanks guys. Cheers.